Welcome back to The Electronics Inside, the show where we tear down tools, toys and appliances just to find out what's inside. I'm David, and in this episode, well, we've covered a lot of cameras already. We've covered the Instax, a Polaroid, the Sony Mavica floppy disk camera, a bridge camera, even a DSLR. So it only seems suitable that we filled in that gap with a point and shoot camera. So as I said, we've covered a lot of cameras, including not just stills, but also video cameras. But we haven't covered a point and shoot, and I'll be honest, this one actually belongs to my wife. We were cleaning out the loft, and there it was. Crusty batteries and all. I should also add, we also found the SD card in it. A beautiful 2 gig verbatim model, was clean and did still work, so I can insert some 10-year-old embarrassing photos of myself. So although I can't find a proper date, I think this camera's from about 2010, looking at the photos we found on the camera. And this is fairly typical for the time, although phones were starting to have cameras. I mean, going from the late Nokias to the early smartphones, cameras existed, but they were not photographically stunning, we'll put it that way. And point and shoot cameras like this, I mean, at this point in about 2010, 10.2 megapixels with a decent focus on it, and a flash was way better than you get on a phone. Let's have a very quick tour just around a point and shoot camera. So nice pop out lens, which may never pop out again based on the state of its batteries. Got the battery box with the SD card slot on the bottom, along with that 1/4 inch thread for tripod mounting. Nothing on the left. On the right, you've got that really weird, offensive USB port type. It's not USB mini and it's not USB micro. To the best of my knowledge, that pretty much only appeared on some digital cameras. And this one is at best full of rubbish. It may well actually be broken. I'm not sure. But that's where the SD card comes in, because we just take that out, put it in your card reader, job done. Nice big screen on the back that takes up almost all of it. Of course, not touchscreen. Arrows, display, playback, okay. And WT for zoom controls. You actually had zoom on this. You don't get that properly optically on phones, even today. Okay, with that sort of rough tour done, I want to bring you in a little closer so we can get the best possible detail. And to do that, I'm actually going to have to bring the overhead camera basically down in front of my face. So bear with me while I sort that out. So I guess the first thing we should do is extract those nasty looking batteries. I'm actually going to be pretty aggressive in removing these batteries. I think I would quite like to get this working again, just because it's kind of a cute bit of nostalgia, but since the batteries have more than likely ruined something permanently, I don't need to be too precious about it. Ugh. Crusty. I mean, these batteries expired in March 2019, so at this point they're only 3.5 years past expiry. Oof. You can see that blue, I think it's copper sulfates that turn blue. But yeah, that's not looking too promising. And there's a piece of something that was probably metallic across the front here, which is no longer, like a grounding tag or something. Ah, I'm pretty sure I say this every time. Capacitors in cameras, they like to hurt me. And this is not a hypothetical, they have. To me that there is no data output from this. You can't plug it into a computer for digital transfer. Oh. That'd be the flash capacitor. Fortunately, these batteries have been dead for a long time, so I don't think there's going to be any charge left in that cap. And 10.2 megapixels, it's not a small amount. I mean, I think we've talked quite a bit in the past about pixels not necessarily being the best qualification for quality. You kind of have to consider sensor size, sensitivity, ISO gains, things like that, the optics throughout. It's not highest megapixels win. They count for something, but not everything. No, just glued on. So you've got the solid plastics on this sort of rubbery membrane, and then you've got tactile domes over the PCBs, breaking the switches. So since that screen was so keen to jump out, oh, that screen's not actually protected by anything. That is the screen. You break that, you could well be in trouble. A little bit of corrosion in that top corner. The button pad is actually plugged in down here, and that just pulled out. I don't think it should have done, although it doesn't look like it's done any harm in just coming straight out. Okay, we've also exposed the ribbon connector for the screen, which is good. So we can get that lifted. Okay, there is the screen. That'll just be an off-the-shelf part. Trying to see if there's anything on here that's identifiable as a date. 2009, week 4609 for manufacturing. That would be in the ballpark. Oh, look at that nice big connection onto the sensor array. Oh, look at that. So you've actually got soldered connections between this board on the top, which goes a couple of tactile domes, and looks like the charging controller for the flash capacitor. And actually the flash as well. Interesting combination there. But yeah, that's those soldered connections up here. And the ones here, which are absolutely covered in crust. Oh, they are not surprisingly the battery controllers, and I've just seen some of the solder mask is starting to lift here where the corrosion is just that bad. Well, that makes me very sad that that one tiny little bit of corrosion that's just crept over from the battery terminals onto the PCB probably destroyed enough of the circuitry to at least make it a very tricky repair. And if you could find one of these that still worked, they're only worth £15-ish. You've really got to question how much of your time it's worth under a microscope with tiny little ceramic coated wires to try and repair those traces, even if the components aren't damaged. Is it worth more than half an hour's effort, an hour's effort? Probably not. Probably not. Oh. Sensor clusters come out. And then put that to one side and come back to it. Okay, flash capacitor, control board, and the flash itself. Which way are you coming out? Oh, diffuser. There you go. And flash, a tiny little flash. And there you go. What's left of those battery contacts? Again, you can just see that blue. That my chemistry is not that good. Is that copper sulfides? Whatever that blue copper compound is from the corrosion between the batteries and the copper in the material. Might even be a nickel compound. Nickel plating on the steel springs. I don't know. If you know, just let me know over at the Element 14 community so I don't have to keep guessing. Right, so I've just spent a little bit of time sort of looking up what these ICs are and how this thing all actually works. So the three big key ICs on here are this one down here, which is a Texas Instruments chip, which is actually the CCD driver. So that directly controls the sensor in the back of here, which we'll get to in a minute. This big one in the center is actually a DSP, digital signal processing, and CPU. It's like a system on a chip specifically for photography. And I suggest that's where a bulk of this miniaturization and cost saving comes from. The fact that that's sort of a digital camera on a chip, almost in a single package. Yeah, you've still got a couple of other peripherals, but that's probably gone a long way to simplify manufacturing and value engineering. This one over here seems to be a memory controller, and it was listed as 200 megabits a second. And I would think that that's used as probably sort of a cache, because when you're reading off of that sensor, it's taking a lot of information very, very quickly. It doesn't have to be a big store, but it has to be fast. And writing straight to the SD card is too much. So I reckon it probably stored to this almost instantly and then wrote back to the SD card in the 2 or 3 seconds following taking a photo. The other ICs up here are just kind of supporting peripheral control. There's a motor driver, just to drive like the motor, which is conspicuously hung off the side of this assembly. So let's put those to one side and find out more. It's like a good little assembly, this one. So the motor is probably the main actuation for when this sort of pops out, because when you turn the camera on, this goes and pops out probably that far, sound effects included. But I think that motor is probably also the one that drives zoom. I have a question for you. When does a ribbon connector become a flex PCB? Because this one went into the ZIF connector on the edge of this board, just like that, to connect to the sensor. But it's also got a load of passives on it. So is that a ribbon connector with some passives on it, or is that a flex PCB with an edge connector? Genuine question. If you know the answer, don't forget to tell me. Element 14 community. It's the best place to get in touch with me and all the other specialists and engineers over there. Ooh, there you go. One CCD sensor. So that's 10mm CCD by the looks of it. And what else has just popped off here? Oh no, something with a spring in it. Okay, that just looks like mounting hardware. Don't need to worry about it then. So I think that would be a 1/4 frame sensor, probably, maybe even an 1/8. I got told off because I said originally these were based on 35mm film sizes or equivalent of, and then I was corrected, it's not, it's APS-C that these are based on. So APS-C was ever so slightly smaller than 35mm, and so that 35mm frame about that big, I guess that's a 1/4 size sensor. Nice tiny little PCB on the side. Appears to have an opening inside the lens that's next to a reflector. I think that's like an optical IR sensor, like a light gate. Haven't quite worked out what it's doing yet, but I'll try to. Again, tiny little light gate built onto this PCB. Obviously showing the home position on whether this is open or closed or something similar. Cog just rolls off across the table. So there you go. You can see the sort of full extent of how far this could extend. And it's not tons, but that was enough to be optically stable. Ooh, that little light sensor was looking through that window on the side. Appears to be looking at this little reflective band. And there's another stop on it there as well. Ah, there you go. So as that rolled around, oh, it's not going to do it for me now. Never noticed that before. It's not even in the middle. Look, it's not in the middle of the round bit. I've never noticed that. But I can promise you this, that's all I'm going to see from now on. There you go. So on that motor, on the actual axis of it, there's that little bow tie shaped bit, and that went to this little light gate on a PCB, so you can actually monitor the RPM speed of the motor as it turned. Feedback on the motor speed, when you already could work out the position of the camera barrel from this mirrored strip. And why is the speed important? Because you're only measuring per rotation, it's got to be speed, too high, too low per revolution. What you don't have is absolute counting of that. You don't know what position it was when power got restored. So it's only speed monitoring, it's not absolute position. Absolute position's closed loop feedback. It's interesting, this last bit of flex PCB is covered in black, and so is this motor, just to make sure it doesn't cause any reflections or light to bounce around inside the optics assembly. There are some of the smallest screws I think we've had on TDI. Absolutely tiny. A pair of tiny solenoid actuators with little levers on the end, spring-loaded. Look at them, tiny! And I'm guessing that wipes two sides of a rolling shutter. Okay, so I'm probably going to do just as bad a job as explaining this as I did when we were doing, I think it was the bridge camera. The aperture is the size of the hole that allows light into the sensor, and the shutter is the bit which exposes, like literally moves out of the way to expose the sensor to the light. Cameras typically have what's called a rolling shutter, which means that hole doesn't expose the entire sensor at once, it exposes a bit at a time and rolls across the image. And that's why some sporting photos and things like that, you can see this sort of distortion where things are sort of slanted because the top was exposed at the beginning and then the bottom later when they've moved position. Artifacts from a rolling shutter. Anyway, what they've done for this is they've used two black C-shaped films of plastic, sort of like this and like this, and each of them is actuated separately by one of those two solenoids. So if you did one first and then followed up much later with the second one, you can see that the entire sensor would be exposed for a long period of time, which is probably way too much light overexposing it, but it's also probably going to lead to various blurs and motion and all sorts of issues with the photo. So what they do is they trigger both of them very close together. So what you get is that hole traversing across the sensor. And depending on how close together they are, if this one goes first, it opens up that hole so it's larger. If you do them closer together, that hole is smaller. So you can sort of see that using just these two actuators and nothing but electronic timing, you get aperture control and you get shutter control in one go. Very, very clever. Really clever way of getting those two things down to the minimal viable product to make it work. Awesome. So I haven't really appreciated what we were seeing here with these point and shoot cameras from about this time period. And it's a really good example of how that consolidation, that system on a chip mentality, that those 20 discrete circuits that we saw in the Mavica, all of a sudden boil down to one integrated purpose-built chip. We saw it with Pong, but I didn't really appreciate that was the trigger that made point and shoot cameras so ubiquitous as they were at this time period. And we all reap the benefits because the only step further from those discrete, from those bespoke ICs was integrating them completely into another device. That's where we see mobile phones. A surprising twist of history there, a bit of history I hadn't expected to see in this teardown. But I hope you've enjoyed it as much as I have, and as always, if you have any questions, the best place to get hold of me is the Element 14 community. Thank you so much for joining me, and I'll see you next time.